Hello and welcome to Earthquake Tip number 24. My name is Shailesh Kumar Agrawal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread right technical information in simple to understand language to our professionals who are in the field designing and constructing structures, especially our architects and engineers. But before we start, let's make a pledge that any new structure we design or build must be earthquake resistant. This earthquake tip number 24 will explain you how to reduce earthquake effects on buildings. So far, through preceding tips, we understood earthquake resistant design and how to minimize damage during earthquakes through earthquake resistant measures. Through this tip, we will try to understand, can earthquake effects on buildings be reduced? Classical seismic design attempts to make buildings that do not collapse under strong shaking but may sustain damage in the building. This may render the building non-functional after earthquake, which may be problematic in some structures like hospitals, which need to remain functional in the aftermath of earthquake. Therefore, special techniques are required to design buildings such that they remain practically undamaged even in the event of severe earthquake. Buildings with such improved seismic performance may cost more than the normal buildings do. However, this cost is justified through improved earthquake performance. There are two basic technologies to protect buildings from damaging earthquakes. Number one, base isolation devices. The idea behind base isolation is to detach, that is, isolate the building from the ground in such a way that earthquake motions are not transmitted fully through the building or at least greatly reduced. Second is seismic dampers. Seismic dampers are special devices introduced in the building to absorb the energy provided by the ground motion to the building. It is like the way shock absorbers in the motor vehicles absorb the impacts due to undulation of the road. Let's now understand them through this figure. The concept of base isolation is explained through this example building resting on frictionless rollers as shown in this figure 1A. When the ground shakes, the rollers freely roll, but the building above does not move. That means no forces are transferred to the building due to shaking of ground, or in other words, the building does not experience the earthquake. Now, let's see this figure 1B. If the same building is rested on flexible pads as shown in this figure, that pad offers resistance against lateral movements, then some effects of ground shaking will be transferred to the building above. If the flexible pads are properly chosen, the forces induced by the ground shaking can be few times smaller than the experience by the building directly on the ground. Such fixed base building is shown in 1C. Therefore, base isolated buildings experience less forces than the buildings which are directly attached to the ground. Now let's look back again at figure 1B. The flexible pads are being explained here. They are also known as base isolators, whereas the structure protected by means of these devices are called base isolated buildings. In engineering term, base isolation technology introduced flexibility in the structure. As a result, a robust medium rise masonry or reinforced concrete buildings becomes extremely flexible. These isolators are often designed to absorb energy and thus add to the damping of the structural system. This further helps in reducing the seismic response of building. There are several commercial brands of base isolators available in the market. Most of them look like large rubber pads, although there are some other types that are based on sliding of one part of the building relative to other. A word of caution here is that a careful study is required to identify the most suitable type of base isolation device for a particular building. Also remember, base isolation is not suitable for all the buildings. It is suitable for low to medium-rise buildings resting on hard soil. The high-rise buildings or buildings on soft soil are not suitable candidate for base isolation. Let me explain you now base isolation in real buildings through this figure. After 2001 Bhuj earthquake, the four-story Bhuj hospital building was built with base isolation technique, as you can see here. Seismic isolation is relatively recent and still evolving technology. It has been in increased use since 1980s and being evaluated and reviewed internationally. Countries like Italy, Japan, New Zealand, and USA are using base isolation in numerous buildings. Further, base isolation is also useful for retrofitting of important existing buildings like hospitals and historic buildings. More than 1,000 buildings world over are equipped with seismic base isolations. In India, after the 1993 Latur earthquake, one single-story school building and another single-story shopping complex building were built with rubber-based isolators resting on hard ground. Both buildings are brick masonry buildings with concrete roof. That was the first demonstration in India. However, as of now, there are several buildings in our country with base isolation. Now let's move to another technique, that is seismic damper, and let's understand this technique through this figure. Installing seismic dampers in place of structural elements such as diagonal braces help in controlling seismic damage in the building and improving their seismic performance. These dampers act like hydraulic shock absorbers in cars, where much of the sudden jerks are absorbed in the hydraulic fluids and only little is transmitted above the chassis of the car. Similarly, in the buildings, when seismic energy is transferred through dampers, these dampers absorb part of it and thus damp the motion of building. Commonly used types of dampers include viscous dampers as shown in this figure 3a. Here, energy is absorbed by silicon-based viscous fluid passing between piston cylinder arrangement. Figure 3b shows you friction dampers where energy is absorbed by surfaces with friction between them rubbing against each other. Figure 3c shows yielding damper where absorb energy by metallic components that yield. In India, there are few buildings with friction dampers. One such 18-story RCC building exists in Gurgaon. This is all about earthquake tip number 24. You can download the tip from www.bmtpc.org. The next earthquake tip, that is tip number 25, will be on why are load paths important in buildings. Thank you very much.